lesson 84. This one is on multiplication of radicals and then functions. So, two different lessons in this problem. So, I want to review something with you real quick, and you really need to pay attention, okay? So, here is square root of 50. And hopefully you remember, whenever you're working with big numbers and you're not able to figure out what is the square root of 50, remember that you can take 50, and we're going to do 5 times 10, and then you take, you're finding prime numbers, right? Mm-hmm. So 5 is a prime number, and then 2 times 5 is a prime number. So we could also write square root of 50 as square root of 2 times square root of 5 times square root of 5. Do you remember that? Mm-hmm. Remember how you can do that?
Yep.
This is the same thing as this.
Yep.
Okay? And then once you get to this point, if you have a square root of 5 times a square root of 5, it just equals 5. Yep. It'd be like this. Square root of 64 times the square root of 64. Well, square root of 64 is 8.
And 8.
Square root of 64 is 8. And 8 times 8 is 64. So, square root of 64 times the square root of 64 is 64.
Yep.
Square root of 5 times square root of 5 is 5. Mm-hmm. And then I've just got square root of 2. And then I just rearrange that because it looks better. 5 square root of 2 is the answer. Mm-hmm. Okay? So that's how you would do that. You got it?
Yep.
Alright. Now that you know that, let's move into doing some of the work, what we've got today. Okay? Square root of 6 could actually be written like what? Square root of 2 times square root of 3.
Yep.
Right? Okay. Knowing that, I could even just say square root of 2 times the square root of 3 and say that is square root of 6. Just like I can say square root of 6 and then turn it into that, I can also take this times this and turn it into this.
Yes.
Okay, you with me?
Yes.
Alright, so now let's take some of the problems they're going to give us today and work it. 4 square root of 3 times 3 square root of 2. Now, when you see these kind of problems, what you're going to do is you're going to multiply your numbers. 4 times 3, 12. Then you're going to multiply your square roots. Square root of 3 times square root of 2 is square root of 6. Okay? And that's the final answer. And you might be thinking, oh, this is simple. Okay? But it gets harder. Okay? So that's how you would do that one. The next one gets a little bit harder. So now I have 4 square root of 3 times 6 square root of 6. Now, the best way to do this is let's go on and do this. 4 times 6 is 24. And then let's go on and do this one. 3 times square root of 3 times the square root of 6 is square root of 18. Now, on these, whenever you get to this answer, we need to ask ourselves, can I go any further? And on the last one, for example, it was 12 square root of 6. Then that would be 12 square root of 2 times the square root of 3, which is the square root of 6.
Yeah.
This doesn't do anything, so we're going to leave it in this.
Yeah.
But this one does do something. So stay with me for just a minute. What could I come up with for 18? Now watch me. I'm going to do 9 times 2. 2 is a prime. 9 breaks down to 3 and a 3. So I could actually say the square root of 18 is the square root of 2 times the square root of 3 times the square root of 3. And that knocks that out. This is helpful to break down to then be able to say the square root of 3 times the square root of 3 is 3. So now, then I've just got square root of 2. So now I've got 24 times 3 square root of 2. So now we just do 24 times 3, which is 72. So the final answer is 72 square root of 2. Do you understand why it was important to go in and break this down? So that we can come up with the smallest version. You want to keep breaking it down. This one, when we broke it down, doesn't matter. Because if I break this down, I can't use the 3 and the 3 or the 2 and the 3 to make anything. So then you just leave it as this.
Okay.
That was the previous one. So do you see how this has no benefit to do anything?
Yes.
We just need to leave it in this form.
Yeah.
But this one benefited to do something because we could break down the 3's. The square root of 3 and the square root of 3 to make a 3 here. Okay, so that's where you have to ask yourself, go on and break every one of them down, but if it doesn't benefit you, put it back into the same place it was. Okay, let's do another one. Now this one looks confusing, but it's really not. Okay, you have to see this as a distributive property problem. Okay, now remember, this is times this. And whenever you're multiplying them, you multiply the numbers, then you multiply the square roots. So let's do that. 4 times 5 is 20. Square root of 3 times square root of 2 is square root of 6. You with me? Plus, now let's do the next one. 4 and 6 is 24. Square root of 3 times the square root of 3 is just 3. Remember, square root of 3 times the square root of 3 is 3. It's like square root of 64 times the square root of 64, 8 and 8 is 64. Okay? So that's good that you realize that you solved square root of 3 times the square root of 3, which just equals 3. And since we're multiplying this times this, then it would be 24 times 3. Okay? You with me? Okay, and then 24 times 3 is 72. Okay, plus, and then 20 square root of 6. And basically, if 20 is a part of a square root of 6, you don't try to add the 20 and the 72. Now, if this had square root of 6, then you would add, but you don't on this one, okay? So it's just,
that's the answer.
That's just the final answer right there.
Okay.
Okay, this won't break down any further, right?
Yes.
Because 2 times 3, okay, so that one just stays. All right, let's do a few more of those just to make sure you're getting it. I think there's one more, yeah. And then we'll move on to the next portion of the lesson. 4 square root of 2 times 3 square root of 2 plus 5. Okay, now here we go. We're going to multiply this times this. 4 times 3 is 12. Square root of 2 times the square root of 2 is 2. Plus, then we're going to take 4 square root of 2 and times it by 5. 4 times 5 is 20, and then square root of 2 is nothing to square root over here, so it just stays square root of 2.
Yes.
Okay, so now 12 times 2 is 24, and then 24 plus 20 square root of 2, and that's the final answer because this one doesn't have a square. Okay? It's almost like you have to see this as elephants and dogs, because this is 20 square root of 2, and this one's just a number, so you don't multiply or add them, okay? Alright, let's go on and to move into the second part of the lesson. And this one is on functions. Alright, this is really kind of what you've been doing your whole life. So, for example, if I have an x and a y, and if my x is a 2, 4, and 7, okay? And hopefully you'll remember functions. And functions are, if I go from here to get this, what happened? So for example, if my function is x squared plus 5, if that's my function, then basically what I do, if I start with my first x,
it'd be 2 squared plus 5.
If I put a 2 where that x is, it would be 2 squared plus 5. 2 squared is 4, 4 plus 5 is 9. So when x is 2, y is 9. If x is 4, 4 times 4 is 16, 16 plus 5 is 21. Okay? If x is 4, y is 21. If if x is 7, then y is 54. You see how that works? This is a function. Now, they're going to get harder, okay? Where they're not trying to get you to come up with, what did I do to get from here to here? They're just going to start throwing numbers at you. So, for example, check this out. I've got one oval that has the numbers 4, 5, and 6. Then I have another oval that has the number 7, 2, and 14. Now, I want to go over a few things. X and Y are what you're used to working with, right? Okay, but do you remember from the previous lessons, we also designated X as domain, remember this, and Y as range. Do you remember that?
Yes.
Okay, very good. So, domain and range. Now, this one doesn't make sense because From 4 to get to 7, plus 3.
Yeah.
From 5 to get to 2, I did plus 3. And from 6 to get to 14, I did plus 3. So there's something, and they're not actually asking you what is the function.
Yeah.
What they're asking you is this. Does this diagram designate a function? Okay, now let me tell you what designates a function, and you want to write this down. What designates a function, is not if it makes sense, like I told you, like you've learned previously. What designates a function is this. If a relationship between the input, which is the domain, so go ahead and write that down. A relationship between the input, domain, and the output, which is the range, is where every input has, and this is so important, only one output. Every input has only one output. Only one. Now I explained to you what that means. Remember how we were putting the x? Remember this function?
Mm-hmm.
The x was our input, right?
Yes.
We put x in, and then what comes out is y.
Mm-hmm.
Okay, so what designates a function is not if we can come up with this, but this. If a relationship between the x and the y is where every x has only one output. Okay, so for example, there's only one output. Okay, so for example, this, they've got showing this. They've got an arrow pointing to that. It looks like that. Actually, it doesn't have the arrow here, but that's showing what's happening. The next one shows this. And the next one shows this. Okay, so let's look at every input. Does it have one output?
Yes.
Input,
Yes.
one output.
Mm-hmm.
Input, one output. So does this designate a function?
Yes.
Yes. Okay, now let's look at another one. I'm going to change all these, okay? So for example, they don't actually label this X and Y or even label this as domain and range. You just have to know, well, they do say domain and range. Yeah, sorry. I didn't realize that. Yeah, that's good. So the next one says, does this diagram designate a function? Y, A, so they're not even using letters or numbers this time. Y, A, M, P, X, 5. Okay? And then this one's what it says. Okay? Now this looks confusing. Okay, so let's ask ourselves, every input has an output.
Yes.
Input, output,
Mm-hmm.
input, 2 outputs.
Yeah.
Does not work.
Yeah.
No, this is not designate a function.
Mm-hmm.
So listening to this is very important. So basically what you realize is this, is that this M can only go to one thing.
Yeah.
So what I always do is circle my letters, okay? If this one's going to 1, this one's going to 1, so I circle the ones that are going to 2. And then I ask myself, okay, this is my input, but it has 2 outputs, okay? And that helps me. All right, let's do another one. All right, here we go. Now this one's going to kind of get confusing because it's going to look like a certain thing. This is domain, range. Here's what it says. A, 4, 7. And then this one says 5 and 11. And then this one goes boom, boom, boom. Okay. Our input has one output. This input has one output. This input has one output.
Yep.
It does designate a function because this one only puts out one output. It's okay for the y, or the range, to be shared.
Yeah.
It's not okay for the input to be shared. The x, the domain. Got it? So you got to ask yourself every time, this A is with this 5, this 4 is with this 5, this 7 is with this 11. That's okay. All right? Now, let me show you this one. Okay, I'm going to come back to that in just a minute. This is 8411, so... Okay, 7, input has one output. Input has two outputs.
Doesn't work.
No. The input cannot have two outputs. Okay? Got it?
Yep.
Alright, now, let's go on back to this one. Here's what they say this time. Oh, I'll just erase it. Okay, this time they just put real numbers on this side. And then they tell me, they just leave it blank, and from here to here, they say y equals x plus 2. This is kind of what you're used to before the lesson today. So if I had a real number, 5, and since this is the x, the domain, and this is the y, the range, if x was a real number, 5, then 5 plus 2 would give me 7. So if I have a real number, will I get one range?
Yes.
Yes. So this is true.
Yes.
Yes, it is a designated function. It does designate a function. Okay? Because you'll always, if I choose 7, 7 plus 2 is 9. I'm always going to get one output from this function. You understand?
Yes.
Okay. Now, the next part kind of looks weird, so stay with me. They're going to start giving you sets. For example, they'll give you this one big little thing like this, and then they'll put 3 sets or 4 sets inside of it. And I'll explain to you what to do here. Alright, this is going to be one of the sets that they give you. Okay, this is A, and I'm actually going to do B first, and we'll come back to A. Okay, so look right here. Okay, we're going to do B first, I'm going to come back to A, and I'll explain why in just a minute, okay? This is X, Y, X, Y, X, Y. So, I always think it's good to do this little example they have. 4, so this is X and this is Y, or this is domain and this is range, however you'll see it. So this is 4, my Y is 8, they go together. This is 15, this is 6, they go together. This is 11, this is 7, they go together. Does this designate a function?
Yes.
Yes. But, look at this next one. And that's why it's best to draw it out. 4. Okay, let's look at our x's. X, X, and X, Y, Y, Y. I have a 4, a 7, and a 4. So what are my x's? 4s and 7.
Yes.
So I don't have to write the 4 twice because I already have a 4.
Yeah.
My y's are 6, 2, 5. Then you ask yourself, 4 goes with 6, 7 goes with 2, 4 goes with 5.
So it's not.
What do you notice?
It's not gonna work.
Input has 2 outputs. This is no. So you see why it's best to draw them out like this? Yeah. And now it's always good to go 4, 15, 11. So then you would write 4, 15, 11. And then 8, 6, 7, 8, 6, 7. And then make them go towards each other as you do it. Okay? So this one was yes and A was no. Alright? Now, on your lesson 84.10 example, I want to review something with you because it kind of gets confusing. So let's do A, B, C, and D together. Okay? And I really need to pay attention when you get to C because it's really important. So here's A's, which these are important too. So here we go. 1, 2, 2, 3, 3, 4, and 4, 5. That's my first step. So let's go on and do these. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4, 5. 2, 3, 4, and 5. And nothing repeated. So 1 went with 2, 2 went with 3, 3 went with 4, and 4 went with 5. This one does designate a function, yes. Alright, let's do B. B says 1, 2, 2, 3, 1, 3, and 4, 5. Alright, if you were to look at this one, let's draw. I have 1, 2, 1, 4. So 1 is repeated twice. 1, 2, and we've already got a 1, so I'm just going to go 4. 2, 3, no, we already have a 3, 5. Got it? So now, 1 goes with 2, 2 goes with 3, 1 goes with 3, 4 goes with 5. So what do you see? This one input has 2 outputs. No, doesn't work. So I'm going to put N for no. Alright, let's do C, and this is the one I want you to really pay attention to. Oh, this next one says 4, 3, 2, 2, 4, 3, 3, 3. Okay, again, my X's are 4, 2, I got a 4, and a 3. My Y's are 3, 2, 3, oops, already got a 3, 3. 3 and 2, 3, 3. Okay, so my 4 goes with the 3. My 2 goes with the 2. My 4 goes with the 3. And my 3 goes with the 3. Are any of my inputs have 2 outputs? 4 has 1 output. 2 has 1 output. 3 has 1 output.
It works.
Yes, very good. This one would probably seem weird because if you were just to look at it, look right here, Isaac. If you were just to look at it, you'd say, oh, I have 2 4s, therefore it has 2 outputs. Right? But that's not how it works. That's why it's important that you draw this. Alright, let's do our last one. Our last one is this. 1, negative 1. 4, negative 1. Negative 1, negative 1. 3, and negative 2. Okay, if we were to draw this, run out of room. I'm going to erase this one up here. Okay? Alright, so I've got a 1, a 4, a negative 1, and a 3. Okay? A negative 1. I've already got a negative 1, a negative 1, and a negative 2. 1 goes with negative 1. 4 goes with negative 1. Negative 1 goes with negative 1. And 3 goes with negative 2. Okay? Does our input ever have 2 outputs?
No.
No. So this one is yes. It works. You got it? Feel like you understand it?
Yep.
Okay, great. Now, let's get to 8412, because I've already done the 8411 before. The 8412 gives me this, 6, 7, 8, no, 6, 7, 5. And then they show me this, 4 and 11. Okay? And then they point to this goes here, this goes here, and then they don't show anything here. You didn't complete it, so this is neither. It doesn't designate because it never was completed.
Yeah.
You would write neither,
Okay.
just so you know. Okay, let me make sure I covered everything. Yep, that's lesson 84. Okay, so I wanted to show you real quick, this is your lesson practice, and you'll get confused if you try to do this on your own. So in your practice, E, they're going to say, refer to problem C. So in E it says, what is the domain of the diagram shown? Well, remember this is domain and this is range. So what is the domain? You would say A, 6, and 7. Okay, and then F goes on and says, what is the diagram, what is the range in diagram D? Now, this I'm just going to tell you what diagram C's is. You would say the range is 5 and 11. So you're pretty much just telling what the numbers are. So just wanted you to know that. All right.